Welcome back to the Aussie Shed, ladies and gentlemen. It's not often I put my ugly mug in front of the camera, but today I'd like to discuss some really important stuff that I feel really warrants a face rather than the educational Swedish hand model that I normally use. The subject of today's video is basic blop. The subject of today's video is basic block and head prep for those looking to extract big power from their VG30. Or to be honest, any other factory production engine making double, triple, even quadruple its original output. I won't be giving any advice on how to make that power. That's all for another video. This video will be focusing solely on simple stuff you can do yourself at home in your shed to increase the reliability and longevity of that big dollar build. It's all pretty labor intensive stuff that back when I was a lad was considered to be standard practice for these type of builds. Sadly, in today's world, it seems that most engine builders are more focused on the final power numbers and not the overall quality and longevity of the build. But honestly, they're not really the only ones to blame. Labour-intensive work that can't be done by machines is expensive, and no one wants to cough up for the costs involved. So in reality, you have three options. You either put in the hours yourself, or you pay someone else to put in the hours, or should I say days involved. Or thirdly, you just skip the whole process, stick your head in the sand, and forget that this is an actual real thing that you should be doing. I can happily pass on the old man knowledge, but only you can make it happen. So, without further ado, let's start at the heads and we'll move to the engine block shortly. Alrighty. So one of the first things you want to take a look at with your heads is casting flash and machining burrs. There is a lot of that on the VG30DETT heads that you really need to take care of before planning on a big build, just purely due to the extra stress that will be put on the engine, the extra forces that will be applied to the block and heads, and also the extra harmonics that come into play with a high revving, high power engine that can cause all sorts of weird things to happen that wouldn't normally happen with an engine that wasn't being pushed to these kind of levels. And by these levels, I mean, you know, above 500 horsepower and up from there. So one of the biggest issues that you'll come across with these heads is casting flash, and there is actually quite a lot of it. On this engine, I've actually already removed a lot of the casting flash. It's really obvious in places like here where a hole's been bored for this head bolt, and there will be like a thin line of casting around it that's very, very thin and very easy to dislodge. Now you can just kind of touch it and poke it and you'll get bits of it breaking off everywhere. And you can see these little pockets are everywhere. You can see where I've come down onto this area here with a burr. So there was just a ledge going across here that had this section that came out to a very fine, flimsy edge of casting flash. And you know, that sort of thing is very, very dangerous to your engine, because again, it's so easy for it to come away. There are so many little dags inside your engine that could potentially cause problems for you. Now, it's really everywhere in here. You can see all of these areas here. They all have little areas that have been hit with a burr. You can see all the way down through here, there was a ledge of casting flash all the way around all of this sort of stuff. And it's pretty gnarly stuff. It's pretty gnarly stuff. The big issue with it is when this stuff comes adrift, where it'll end up is in your bearings, particularly in the top here. So basically your oil filter doesn't get a chance to pick it up before it runs through the oil. It can quite easily contaminate all the oil that's flowing around inside the heads and end up in one of the bearings, marking up the camshaft and all that sort of stuff. I'll talk about this more when we get onto the engine, but often when you have scoring on your engine bearings and stuff, it's related to not particularly mechanical failure, but bits of crap that have come adrift from inside of the engine. If you've ever wondered how that stuff gets there, when you're so particular when you change your oil and your oil filters, and the engine was assembled in a clean room, and it's all been really well put together, and all of a sudden you're picking stuff up in your oil filter and you've got markings on bearings when you're pulling it apart. It's because that stuff was always in there, and this is one place where it definitely comes from. So if you are planning a high performance build on your VG30DETT or any other engine, really, you really need to look into basic block and head prep before you even start with thinking about, taking it to a machine shop. Not that they won't do that stuff for you, but it's very basic labor intensive work that you can complete yourself with a few basic tools. All you need is an air die grinder and a few burrs, and you'll save yourself a lot of money, and at least you'll have the peace of mind in knowing that it's all been done and all been done properly. Because as I say, this stuff is absolutely everywhere. Every hole, every penetration will have been done roughly and will have casting flash around it. Another one here, typically everywhere. And you can see where I've been with the burr and gotten rid of all that loose stuff. Here's another typical example. This is just around one of your spark plug holes. But the machining for your valve spring pockets and all the rest of it that's actually within the oil flow in the engine is exactly the same and suffers from the exact same problems. Now, this isn't in a position that's going to cause problems for your engine, but this is typical of the edges that you will find remaining on things when you look inside your heads and inside the engine. So you've got this type of thing here, right? And if you look at this, how easy that comes away. So you can imagine if that's actually in a spot inside your engine where you are going to be getting oil going through it, which is very, very common indeed. And there is lots of these, how easy that breaks away. And the thinner it is, the easier it breaks away. And in some places it is paper thin, and you've only got to touch it and it comes away. So you can imagine your engine's doing 8,000 RPM and pulling friggin' 700 horsepower. And there's a lot going on in there. And to have these little loose flaps of aluminium that are just waiting to come adrift is not something you particularly want. That's not so much of an ordeal. That's just sort of a bit of a mark in the casting. It's more just wherever there's been any machining, and if there's any major flash in an area, which will usually be around something that's been machined as well, you'll get situations where something's been cut and there'll be a burr left on. Let's see if I can find anything. I spotted something on one of these heads earlier. Oh, okay, here it is. Where are we? Ah, see that? So this is an oil gallery that feeds the lifters and cam bearings on one side of this head. Okay, so if you look at the one next to it, when that's been cut, when the lifter bore has been machined into there, it breaks through into that gallery. Okay, and it's meant to do that. That's all good. But you can see, have a look for some little fine dags. But then when you get to, say, this one, look at that. So I'll just grab a trusty tool in here. These dags on this lifter bore are quite possibly exactly what I'm talking about. They may have come adrift from some part of the casting in the head and then embedded themselves into this lifter bore, because they do appear to be squashed into the aluminium, and they're attached fairly well, but it is absolutely possible that any time they could come adrift, head back into this oil gallery, or end up back down inside that lifter bore and just continue through the top end and into these cam bearings. It really happens that easily, guys. You've just got to go over absolutely everything with a fine-tooth comb and just knock off all the edges on stuff, and make sure there's nothing that can come adrift anywhere. Absolutely anywhere. Even around things here like this plug, there will be burrs. Look at that. That just break away How easy is that? Watch this. See that little bit there? Watch me get rid of that. Look at that. Just touch it. Just touch it, touch it, touch it, touch it, and it all just comes off that easily. And that's how easy vibration in your engine can dislodge this sort of stuff. Very, very easily indeed, guys. So, basic head prep, that's what it involves. I'm not going to get into things like, you know, porting for performance and valve size and all about and anything like that. This is just about basic prep for a high horsepower engine. A lot of this kind of real basic stuff seems to have been lost over the years. It was the way that things were always done back in my day. Anything that we're spending money on and expecting to perform well beyond its intended use, you always put major effort into block and head prep. Now, this is something that most people probably won't do, but I actually deburr the outside of the heads as well, just because there's heaps and heaps of really sharp casting flash on the outside of your heads as well. It's just everywhere. And if you're going to be handling these things a bit, they'll cut you to pieces. And because I am going to be reporting and doing a lot of work in the valve areas and other parts on these heads, I've gone around and I've deburred all the outside. Here there's like razor sharp casting flash that runs around all of this kind of stuff in between all the ports. Everywhere you can see shiny bits where I've deburred it. It was just, you know, really messy stuff. So again, that's not a necessity. That's not something that you absolutely have to do for the sake of the engine. But for the sake of yourself and your hands and a couple of extra minutes work while you've got the die grinder out, it really pays to externally deburr stuff as well. All right, that'll do us for the heads. Let's move on to the engine block. So, the mighty VG30DETT. You've seen all the work that I did previously on the main water gallery running through this thing. That is an absolute must. Again, if you are serious about your engine build, you must pay attention to that stuff, because it is of utmost importance to make sure that you keep all the cylinders evenly cooled. Don't have one that runs hot. If you have one cylinder that's running hot, it's going to be more prone to detonation. It's going to hold your tune back on your engine. So with any engine, it only makes power equivalent to the lowest denominator. So if you've got one cylinder holding the engine back, that's how much power it's going to make. It's not going to make the power that the most powerful cylinder makes. It's going to be making the power of the weakest cylinder. So we've got to bring everything up to the same specifications, whether that is related to making power or keeping the engine in a state where it can make power. So as I say, water jacket stuff, I'll leave a link to a video right there that I did showing how to do that. And once you take care of all of that, you really need to get inside the crankcase area and start deburring in there, because there is so much shit you really need to get rid of. All right, I'll flip this engine over. We'll have a look inside. All right, that's a bit better for what we need. Okay, so the first thing I'd like to talk to you about is casting flash again, related to the cast iron block this time, and casting imperfections that are sort of rampant throughout the crankcase area. The rough cast finish in this crankcase area has a lot of sand inclusions in with the surface finish. It's just typical of cast iron. There is really no way around it, which leads you into a position where if you're really serious about the engine, you have to do something with that. And really, realistically, the only way to deal with that is to get rid of it. It's particularly prevalent in internal corners throughout the crankcase area, which tend to be a lot rougher and just by nature have a lot more sand inclusions within those areas, which are just waiting to come away, you know. It's just an unfortunate reality of the situation. So you just have to deal with it and get rid of it. Any casting lines like I'm digging around with here, they need to be removed, because any lines like that have stress risers built into them, which means if there's any movement within the block, they will tend to start to shift where there are any hard corners and straight lines. You also have things like this ledge here that I'm sticking my finger in. which the underside of anything like that creates a bit of a ledge, the underside of it will be particularly rough and coarse and have a lot of casting sand included in with it. And it's just a haven to firstly collect anything that's floating around inside of the engine, and also for itself to shed bits of sand or bits of metal at random times off into your oil when the engine's going through a major load moment or a major harmonic situation, which completely upsets the engine block. Again, majorly rough areas that are just features of the casting create the same thing. They're just problematic areas that need to be cleaned up just to eliminate them from becoming a problem in the future. The next thing we need to deal with is stress rises. Now, stress rises can occur everywhere where you have a hard edge on anything. So removing stress rises basically involves removing all hard corners on everything in the block, all the edges of the oil pan rails, all of the edges of the bearing carriers cast into the block, around the base of the cylinders, any of the webbing onto those main bearing carriers, just basically any features in the bottom of the block that have a hard corner on them. Those edges need to be knocked off in areas that you can't physically round them off, or if they are in an area where you have the ability to round off a corner, then you really should round off and blend things together as much as possible. Obviously you can't do that with the main bearing carriers, but you can do that in other areas. You can see that in features like on the back of the engine here, where you have the thrust bearing, where from the factory they've taken the edge off the corner to help with this regard, but they haven't done it anywhere else. And the reason why this happens is when the engine is twisting and torquing and under a lot of load, if you have an area that's trying to bend and you have stresses running against a corner, it can start to fracture on the corner, and that fracture can slowly get bigger and bigger and bigger until it forms a crack, which will eventually end in a major failure. And by breaking those edges and rounding off some of those corners, you remove the ability for those hairline cracks to begin. They just don't start because that stress point is gone. You've now got a nicely rounded off area that is a lot stronger than the sort of point of the corner. And basically most of those stress points will just actually never occur. It just makes things a whole heap stronger. So yeah, de-stressing the block, removing corners, removing stress rises, anything that's sharp, anything that's got a hard edge on it, you've just got to knock it all off. And basically what you end up with is a polished crankcase. If you've ever seen a race engine or an engine that's had a lot of coin and a lot of time spent on it, when you have a look in the crankcase area, it will be polished or appear to be polished to the eye. They're generally not fully polished, and this is the reason why. And they often are painted as well in the crankcase area. That's only done after they have had this process done to them, and the painting is usually a step further than just de-stressing and deburring, and that's just a helping oil return. But you do get a massive helping oil return just by cleaning up the crankcase area anyway. Not that that's the main motivational force behind it, but it is a byproduct of doing all of this extra engine prep in the bottom end of the crankcase. So as I talked about with the heads, this kind of thing used to be standard practice when I was a younger man, when we were building engines. For basically anything, whether it was a cast iron V8, you know, a high performance straight Japanese 6, basically anything that we would build, if someone was sinking decent money into it, it would have a whole heap of just basic block and head prep done before the build was started. Plus, it gives you a good opportunity to look over everything while you are doing this kind of stuff. It's amazing what you will see and learn about your engine as much as you can just by looking into it in great detail. You basically will become one with your engine. And if you carry that ethos through your whole engine build, mate, you'll have a sweet little package at the end of it. It's all about attention to detail, and it's something that was never done with this engine when it was built. And this engine is the perfect example. It's an engine that had a lot of money poured into it by one of the previous owners and was just built quite poorly and sloppily by the company and the engine builder that did it. And, you know, it never made decent power. And as you will have known from the teardown that I've done on it, there's been various issues that we've come across in the teardown, which has all been due to the way it was assembled, basically. And honestly, for the amount of money that was that the customer had paid for this engine, you would assume that all of this basic work had been done to the engine. You would assume that the water galleries had been cleaned out, the block had properly been prepped, the heads had properly been prepped, because that's what you're paying the big bucks for. And unfortunately, if you know, you're having something this done and you haven't done your research and don't know exactly what to ask for, and in turn from that know exactly what you're getting, it really puts you in a position where you're kind of flying blind with people who may or may not take advantage of you for that reason. So get schooled up on it, guys. Get a few tools, get in there yourself, have a crack at stuff, or at least use this video as a reference so you can take it to the guys who are doing your engine and say, I want this done. And at least you'll be in with a chance. All right, I'll get stuck into this, and I might give you a quick squiz at the block after it's all been cleaned up. All right, bye-bye. And there you go, just quickly. That's what she looks like after a few hours with the die grinder using a burr and a few cartridge rolls and stuff. Hell of a lot tidier. All the hard corners have been knocked off across all these rails and all that sort of stuff. It's all now quite smooth. You know, as I say, the edge of the main bearing carriers in the block, just everything, every sort of sharp edge, all this sort of stuff where there was like a hard corner, that's just been like rounded off and blended in. And basically the same thing everywhere. These little webs on the side, corners have been taken off those and they've been just kind of blended. And that's all it is, guys. That's just to reduce stress rises, basically. And it also gives you a really good opportunity to have a look right over the block and spot anything. And also obviously getting rid of any casting flash that that's in there, you know. Overall, not a huge amount of work, but pretty happy with that. So, if you are planning a high power build, all this kind of stuff is what you really have to get your head around. Again, it's stuff that is just really labor intensive. So if you're paying someone else to do it, it's going to cost you a lot of money, which is why a lot of people just simply don't do this sort of stuff or get it done. Or if you're doing it yourself, you've got to have the tools and you've got to be able to devote the time to getting it done. But as I say, this sort of thing used to be standard practice. Deburring everything, getting rid of all the casting marks and casting flash, getting rid of stress rises on everything, and just making sure it's 100% right before you go about a high power build. Alright guys, I hope you found this video helpful in some way. And if you are planning a high power build, take the tip from Trevor. Get stuck into this sort of stuff, do a bit of research, come to your own conclusions of course, but you're certainly not going to make things any worse by doing something like this. Alright, as always guys, thanks for stopping by the Aussie Shed. Always a bloody pleasure to have you here. If you like the video, give it a thumbs up, subscribe to the channel, leave a comment, and as always, I'll bloody well see you on the next one. Cheers.